Financial Modeling, Topic 13, Forward Contracts, Section 3. Calculating forward payoffs and construct forward hedges using beta and correlation. So let's talk about the payoffs of a forward contract. In other words, the cash flows at maturity for a forward contract. If you're the buyer in the contract, you will take delivery of the asset at some quantity Q and pay the forward price, your obligation. Now the buyer's payoff is the difference between that forward price F and the spot price at maturity. We'll call that ST. The buyer is said to have a long position in the forward since they will profit if the spot price at maturity is above the forward price. So we'd say the payoff for the buyer, if they enter into a forward contract today that delivers the asset at time T, their profit is the difference between whatever the spot price is at the maturity of the asset of the forward contract and the price in which they are required to pay. And you can see the signs make sense because they're going to buy at F, that's why it's negative. They'll then sell it into the spot price at ST, and they'll make profit if ST is greater than F. Now the other counterparty of this contract, the seller, also called the short party, will at maturity receive the forward price as they deliver the asset. Now if they go out and purchase the asset in the spot market, they'll have to pay the spot price to deliver and receive the F0. So their profit is the difference between F and S, not S and F. So let's talk about hedging with forwards. Say you own an asset and you want to guarantee a price to sell it in the future. You could simply short or sell a forward contract. In other words, you are the seller counterparty in the contract. And examples of these are ranchers that want to sell beef, miners that want to sell gold, exporters that want to sell foreign exchange, energy companies that want to sell oil. Now, if you plan to buy an asset in the future, you want to guarantee the price to purchase it, you go long the forward. In other words, you're the buyer of the forward. In that case, examples are an airline wanting to purchase jet fuel, restaurants wanting to purchase beef, a jeweler wanting to purchase gold, an importer wanting to purchase foreign exchange, an investor wanting to buy stock, and so on. So let's do a simple example. Say you want to, it's May, and the New York Harbor Heating Oil number 2 on the Chicago Mercantile Exchange, or I'm sorry, the New York Mercantile Exchange, the NYMEX, is selling for $1.80 per gallon for 1-year delivery. And your factory requires 100,000 gallons. Next year, she could enter into a contract to buy 100,000 gallons at $1.80 for 1-year delivery, and there is zero risk. 1 year will roll around after she purchased that contract, and she will simply take delivery of 100,000 gallons and pay $1.80 per gallon. Let's talk about a more interesting one, and this is called cross-hedging. Say Southwest Airlines would like to hedge the cost of 100,000 gallons of jet fuel in 1 year. Unfortunately, the jet fuel forward market doesn't provide enough liquidity. There's no counterparty out there to take that position. However, there is a very liquid market in heating oil and regular gasoline in the forward markets. So what Southwest could do is they could enter into a forward contract to buy oil or gas to cross-hedge the cost of jet fuel. So a basic term, cross-hedge, is a hedge using an asset that is correlated to the underlying asset, but not the underlying asset. And that hedge will be effective as long as gas and oil are correlated to jet fuel. So I got some data here. I have heating oil percent changes in price, gasoline, and jet fuel. And I did a correlation matrix, and I found that heating oil is very highly correlated to jet fuel, 97%. So they tend to move together. So if Southwest is trying to determine which asset is most correlated, they determine that jet fuel is most correlated to heating oil. So what Southwest is going to do is enter into a contract to buy heating oil. And let's say jet fuel is selling for $1.50 in the spot market, and heating oil is selling for $1.60 in the spot market. And they need to buy 100,000 gallons of jet fuel in 1 year. So in this case, what we're going to do is going to calculate how many gallons of heating oil do they need to purchase to hedge their 100,000 gallons of jet fuel. And what they're going to do is they're going to buy a forward or into a forward contract to purchase 93,750 gallons of heating oil to hedge their 100,000 gallons of jet fuel. How will I get that? I'm going to calculate my optimal hedge quantity, H star, assuming that oil and gas move 1 to 1. In other words, if heating oil is up 10%, jet fuel is up 10%, have a beta of 1. That optimal hedge quantity is the spot price of their underlying asset, jet fuel, times the 100,000 quantity, divided by your hedge asset, heating oil's spot price. So again, these are not the forward prices, they're actually the spot prices used to determine the optimal hedge quantity. So if heating oil is selling, or for jet fuel is selling for $1.50 and heating oil is selling for $1.60, I'll simply take the value of that jet fuel today, divide it by the price of heating oil today, and determine the optimal hedge quantity. Hedging is the purchase of 93,750 gallons of heating oil for a 1 year delivery. Now let's see how effective this hedge is if they move 1 for 1. And let's say that heating oil and jet fuel are both up 20% next year. Let's see how this hedge actually works, how this cross hedge works. Now, Southwest is simply going to pay for jet fuel next year in the spot market. So if the current price of jet fuel is $1.50 and it goes up 20%, it's now selling for $1.80 next year. So they're going to pay an extra 30 cents for jet fuel. They're going to pay an extra on 100,000 quantity. They're going to pay 30,000 more for jet fuel. That's if they're unhedged. However, they've entered into a forward contract to buy 93,750 gallons of heating oil because they knew the prices moved together. If heating oil is also up 20%, heating oil goes from $1.60 to $1.92. At the end of the year, they will purchase the heating oil at the forward price of $1.60 and then simply sell it into the spot market at $1.92 on a quantity of 93,750. They will make a profit on the hedge of $30,000, which will perfectly offset the incremental costs of jet fuel. So that's an interesting example of using a cross hedge. As long as the assets move together, you're simply going to take the profits from heating oil to offset the additional costs of jet fuel. Now let's talk about what if they don't move 1 for 1. In other words, the beta is not equal to 1. Well, we can calculate the beta between jet fuel and heating oil, and I did that right here. The beta is equal to 1.03, looking at the slope of jet fuel, and then the slope of jet fuel versus heating oil. So jet fuel is about 1.03 or 1.04 beta to heating oil. So if heating oil is up 100, jet fuel is up 103. I can then use that information to get an optimal hedge ratio or hedge quantity. I simply take what I did in the last section. I calculate the optimal hedge ratio, assuming betas are equal to 1, and multiply times the beta. So I'll take that 93,750 and multiply times the beta. So what I need is actually 97,190. A way of thinking about this is jet fuel is more volatile than heating oil by about 4%. Therefore, I just need about 4% more contracts. So their prices will offset. And then I just said, what if that beta is realized? In other words, what if heating oil is up 20% and jet fuel is up 20% plus that beta? That means jet fuel costs them $31,000 more because the price is up 20.73% versus heating oil being up only 20%. So jet fuel goes from 150 to 181, which is a 31,000 increase in cost. However, they now have 97,190 contracts in the heating oil, and heating oil went up by that 20%. And again, they're almost perfectly hedged. It's just a rounding error in here. So, if your asset is more volatile than your hedge asset, your underlying asset is more volatile, has a higher beta than your the forward contract asset, you just simply increase the quantity by the beta. That optimal hedge quantity is the spot price of your underlying asset times the quantity that you desire over the spot price of that hedge asset. As a summary for cross-hedging is hedging an asset with a different forward asset. In other words, hedging, say, jet fuel by using a forward contract on heating oil. Examples are an airline hedging jet fuel with crude oil contracts, a corporation hedging Danish crown revenues with euro forwards, or Hershey hedging Ghana cocoa costs with Ivory Coast cocoa costs or cocoa forward, or hedging a single stock with with a forward asset of the S&P 500. The steps to establishing a risk minimizing cross hedge is you simply choose the hedge instrument with the highest correlation. You then compute the beta to determine the optimal hedge ratio. And I just wanted to show you one last graph before we move to the next section. One thing people get confused about is the difference between correlation and beta. So here's a picture. Say we look at the return of some portfolio P versus the return of the S&P 500. And then I plotted points of the returns of those two assets using XY scatter. And I plot those points. The slope of those points is 1.4. That is the beta. And here's another example where I did a plot of the returns on a portfolio versus the returns in the S&P 500. The slope of the best fit line is the beta of 1.4. Now the fit to that line is the correlation. So in this case, there are little errors in the differences. So even though both these pictures are a beta of 1.4, it's just the relationship between the two variables. The strength of that correlation or that relationship is measured by the correlation. So in this case, we have correlation equal to 1. It's perfectly correlated with a beta of 1.4. And this is a correlation less than 1 with the same beta of 1.4. Now, when cross-hedging, the standard deviation of the cross-hedged position will be the unhedged standard deviation times the square root of 1 minus the correlation squared. And I'll show you what that means in the example in the next section. So you're able to reduce your standard deviation of your position's risk by the square root of 1 minus the correlation between the two. So in this section, we calculated forward payoffs and constructed forward hedges using beta and correlation. In the next section, we're going to simulate these strategies.